All right, well, welcome to HVAC Trends. What does A2L and SEER2 really mean? At the end of the day, there are new trends happening in the HVAC field. Many of them we cover here, many different topics, especially around electrification and heat pumps. But there's a lot of other things going on here on how to properly evaluate and understand the energy efficiency of some of the new systems that are coming on, and about some of the new refrigerants that are coming on that essentially have less embodied energy or greenhouse gas. And so, whether you're the actual HVAC contractor on the ground doing this work, or whether you're a homeowner or a developer planning a project and wanting to understand how to properly, communicate these things to your mechanical contractors or the architect, these are important things that you want to know if you're trying to do high performance homes, certified homes, or even meeting the codes and basic standards. So that's what we're going to be discussing here today. Now, before we get started, we want to give our GHI membership spotlight as we often do. We want to say a huge congratulations to not one, but three GHI members who came together and achieved the Green Builder Media 2025 Home of the Year Award. GHI members, the Bell residents, along with Architectural Resource and Fireside Home Construction, built this FIAS Core Zero certified home. And you can learn more about that award at greenbuildermedia.com under their January-February 2025 Green Home Year link. You can also watch a continuing ed webinar on this on the GHI YouTube channel. The reality is this home is an inspiration to any type of home on how to build better, no matter the type of size or budget. So we hope you'll be inspired by it. And this is who GreenHome Institute members are. This is what GreenHome Institute members do. Learn more and support us at greenhomeinstitute.org/become a member. Also, before we get started, we have to remind you that support for the GreenHome Institute comes from Build Equinox. Traditional ERVs and HRVs provide basic ventilation, but often lack protection against airborne threats like viral spread and wildfire smoke. Introducing the SERV, an advanced indoor air quality management system, it offers an energy recovery ventilation along with enhanced protection and intelligent air management. It's continuously monitoring pollutants in the air to save energy and only filter and ventilate when those pollution thresholds are reached. It has a high efficiency heat pump to precondition and dehumidify incoming air. It operates in recirculation mode to purify the house. Um, and it has an optional UV light technology to sanitize the air. They also have an institutional for their commercial projects for the SERV 1000 for classrooms and commercial spaces with a cold climate heat pump in it. So learn more over at buildequinox.com to check out the SERV. All right, well, welcome again, everyone, to HVAC Trends. What does A2L and SEER2 really mean? This course is brought to you by the GreenHome Institute. The GreenHome Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. Today, I will be your moderator. My name is Brett Little. I'm the education manager here at the GreenHome Institute. This course is approved for multiple continuing education units, including our Certified Green Home Professional designation. Got a few too many there, but it should be under Health, Energy, and Materials only. AIA Health, Welfare, and Safety may make it applicable to your state-based design or contractor license. Check out the FIAS code at the end. You'll receive it as long as you're here for the CEU approved hour and appropriately logged in. So with that, I'm going to welcome our speaker here, Matt Dunham. And Matt, thank you for joining us and walking us through this. Please take it away.
Okay, well, it's a pleasure to be here with you guys today. I live in Michigan. The last 3 days, our record high for the last 3 days was today. We're up to 16 degrees. So as an HVAC contractor, this is kind of like our Super Bowl. So we have been very busy the last few days. As a matter of fact, I even slid in a couple of calls this morning. So I apologize if my hair is disheveled and I still have my sweatshirt on because it's been cold and I had a hat on. So we're going to talk Couple of things that come up frequently. I am involved in a couple different groups within our industry, and there's a lot of talk about changes that are happening, and there's a lot of incorrect information out there. So my hope is that by the end of this time today, you will have a better understanding of two of the terms that are being thrown around, and kind of where they came from and what that means moving forward. So, a little bit about what we're going to do. We're going to talk about the differences between SEER and SEER2 equipment. So, for many years, we've been using the term SEER. We're going to talk about what this new SEER2 meant. We're going to talk about what we should be looking at within our systems as our potential performance indicators of if we're meeting the requirements of this SEER2 equipment. We're also then going to look at refrigerants a little bit. So there's a lot of conversation happening right now. We are experiencing this change in what's available to purchase. And so we're going to talk a little bit about those. So hopefully, as we're going out there into the world, we can make informed decisions about what's going on, and also be aware that if someone is sharing information with us, whether or not that is good information. And then we'll talk about for those who may be a little more hands-on out in the field, what are some things that we need to be looking at? I've been in the industry long enough to see if this is my second change in refrigerants as far as one being phased out and another being phased in. And when it happened in 2010, it required a large amount of equipment and tool changes in how we did business. So we'll talk a little bit about that as well too. As a homeowner, uh, I will tell you that it's going to be more expensive. I got an email on Monday that April 1st, my equipment costs are going up between 7 and 10%, and it sounds like that's pretty standard across the board. Um, so a little bit about myself. I am married to my lovely wife, Kelly. She took that picture at some point in time. It was the best picture I could find where I had a beard. I went many years without it, and so people don't recognize me if I show them a picture with it. We are the parents to four lovely kids. Boy, I just realized I picked a picture with Wilson straight up bawling his eyes out. He is now 4. That's about a 3-year-old picture. So that's awesome. They are in school today. Thankfully, they've had a couple of days off for snow recently. And but I do what I do so that I can take care of those 5 people. A little bit about my professional background. So down in the bottom left, you have the logo of the Ferris State University, their HVACR program. I completed that program back in the early 2000s. I have my bachelor's from them in HVACR engineering. And so a lot of the concepts that we're going to talk about, um, we can get down into the nitty-gritty engineering stuff if folks are interested, but I really try to keep it at a higher level. I spent about 10 years working for a company called T.H. Eifert. We were a full-service mechanical contractor. I predominantly did commercial industrial automation systems. It opened the door for me to work on the world's first triple platinum LEED certified building. It's the Chrisman Company headquarters in downtown Lansing. It received 2 during construction, and then after the first year operation, we were able to help them achieve an Energy Star for their building of, I think it was 84, and we got O&M was the third platinum they qualified for. So it really got my toes into kind of what was happening in that space. I spent then 10 years teaching this at Lansing Community College. So as a full-time professor and administrator, among other things, spent time educating our industry. And then about almost 3 years ago now, I felt led to step out from the education space back into the contracting world. And so I opened Dunham Service Heating and Cooling. We are also a full service mechanical contractor. Today, to help my guy out, I've already been in a commercial building looking at a rooftop unit replacement, and had a conversation with the owner about why their economizer was important, because the last rooftop they had swapped this fall, the contractor didn't put the economizer in. And then I also was looking at a residential house just down the road from us that didn't have heat. So we kind of take care of whatever our customers' needs are. Um, so let's jump into maybe some terms we've heard before, but a lot of times if you're looking at air conditioners, you'll hear folks talk about SEER. And I would also say, uh, if folks have questions, Brett and I already talked about this, feel free to drop them in the chat. After 10 years of teaching, I'm totally fine with being interrupted if a question comes up pertinent. I also have 4 kids who are like chasing squirrels. So we won't get sidetracked too far. If you have a question, we'll pull it back as needed. So SEER, if you've ever bought an air conditioner or looked at an air conditioning system, this is the rating that normally gets thrown around. It stands for Seasonal Energy Efficiency Rating, ratio. My slide's wrong. Ratio. It's the Seasonal Energy Efficiency Ratio. This is a simple calculation of looking at a total cooling season. So a total season of cooling, entire year of cooling. What is going to be the total cooling output? And then you divide that by the total energy input into the system, which they calculate at watt hours. So when you have what you're left with when you take BTUs per hour and you subtract watt hours or divide it by watt hours, you're left with this multiplier. And over the years, they've been as low as like 8s and 9s. So if you have an air conditioner that was installed in the late 80s, early 90s, likely it had a SEER rating of, 8 to 9, maybe 10. Um, and then all the way up to, and we'll talk about how those changed over time, much higher now. So the bigger that number is, the bigger that SEER rating is, the better. Um, these numbers are calculated in a lab condition. So 2 falls ago, I had the opportunity to tour Dakin's manufacturing facility down in Houston, Texas, and got to see where equipment is in the R&D, and they are testing it and they are running it through these um, the paces that it has to make sure that it's performing the way it needs to perform. So it is a cool thing, but it is basically happening in a laboratory setting, which can be very far removed from what actually happens in the real world. And then I kind of started alluding to this, but over the last, well, I've been in the industry over 20 years, we've seen the minimums increase. So it used to be a 10 SEER was considered a pretty standard unit. Early 90s, that was a very common unit to see. Over time, those minimums have increased. So I threw up just some generic pictures, not endorsing any of the brands here, but they were the best representations I could find. If you see a very small, older unit, um, a lot of them were like 2 foot by 2 foot by 2 foot, so a little 2 foot cube. Those are likely on their best day, brand new from the factory. They were performing at about a 10 SEER rating. Uh, Early 2000s, probably 2000. It was right around 2010. Um, they upped the minimum. The minimum went from 10 to 13 to 14. And so if you see something that is a little larger, maybe 2.5 foot by 2.5 foot, around 3 foot tall. That has a tendency to be around a 14 SEER unit. And then if you see something that looks like a small shed next to the house, typically they're like 36 by 36 and 48 inches tall. So 3 foot by 3 foot, 4 foot tall. You're probably looking at something with like a 19 to 20 SEER unit. Um, this was the solution was, okay, we need to improve our efficiency. How can we do that? Well, we still need to move the same amount of BTUs, but we need to, so the top of our equation is going to stay the same. We still need to move those same BTUs, but we need to do it with less electricity, which will lower our bottom number, which will give us a larger rating. Um, and so the easiest way for manufacturers to do that was to increase the size of our coils. So as our coils got bigger, we have more surface area. More surface area means more heat transfer between the air and the indoor and outdoor coils. And so the more heat transfer we can have over a larger area, the less difference in temperature we need between the coil and the air. Therefore, we can lower the compressor ratio, and the lower my compression ratio, the lower my energy consumption. So for many years, the solution, probably the last 20 years, was let's build bigger and bigger units, and that will make us more efficient. And so that same standard has been used for many years. A couple of years ago, they said, well, the Department of Energy said, well, we appreciate the ratings that you're applying. These really aren't realistic real world conditions. So again, I mentioned that we were testing equipment in a lab, and we were testing it based on that lab setting. It boiled down to, in the bottom right corner of the screen here, it says SEER was was running the equipment with a zero point zero 0.01 total external static pressure. So the total external static pressure is the difference in pressure between the blower cabinet on the furnace and the discharge air of the furnace. So if I guess I didn't check to see that this would work. Oh, back up one. Um, I used to use a different program when I was teaching like this. Hold that. That's what I was looking for. So the filter on this furnace is going to be right in here. So if we were taking the total external static pressure of this furnace, we would go from inside the blower cabinet down here to directly above the furnace here. Now, this furnace does not appear to have an air conditioning coil above it. And so um, we need to know what the total external static pressure is just over the furnace. If this had a coil, then we would be going above the coil up that. So that total external static pressure is basically how much work does the furnace blower have to do to move air through the system. Realistically, in homes, we're looking a more real world application is a 0.05 total external static pressure. I will let you know that I have seen furnaces running in the field that are in the 0.08 to 1.0, which is outside manufacturer's recommendations, but it's what happens in the real world. So back in January, so as of January 1st, 2023, these manufacturers were required to change their test parameters to get a more realistic idea of how this equipment was really going to rate in the field. What that resulted in for a lot of equipment was approximately like a zero point 0.6 to a 1.0 reduction in rating. So what was a 15 SEER unit now generally is seen as like a 14.3 SEER2 unit. It doesn't work perfectly on every model from one to the other, but that generally is how it worked out. And most of the time, um, it's within about one. Um,
So Matt, do you know how much does the SEER2 also sort of evolve the HSPF or COP ratings on heat pumps at all? Does that also go change along with all of that, or what's the impact there?
so yes, the same rating changed those as well too.
Okay.
It Each one of those is a slightly different ratio for calculating performance. Um, and you will see a similar slide on those as well too. So
Okay.
it's similar to what we're seeing here. The big one, like when you talk heat pumps, is the EER2 rating.
Right. Yeah.
Um, and I don't have a slide on this because I don't know the final answer to it. so I didn't want to put it in writing. The biggest challenge with some of the new equipment we're seeing today as these ratings, whether it's SEER, EER, or the HSPF,
Yeah.
the
One of those
whatever
acronyms.
the heating rating one,
Yeah, one of,
whatever is they are accounting for the unit to be running at 100% capacity. Because for years, when we turned an air conditioner on, we turned the compressor on and the compressor ran at 100% capacity. Um, the reality in our industry now is we have inverters on a lot of equipment,
yeah.
and those inverters spend very little time running at 100% capacity. But to test them, they have to be tested at 100% capacity. So the testing assumes you're running at 100% capacity all the time. However, when we put in a modulating heat pump that has an inverter drive on it, um, there will be very, very small portion of its lifetime spent running at 100% capacity. I know that there are a couple of big manufacturers that are advocating to the government to develop a better testing parameter so that we can more fairly compare um, apples to apples as far as performance. So I know with the brand I represent, I could sell you a 19.2 SEER two stage. That would be like an ice cube, similar to what I showed you on the screen. Ice cube because it's a big cube unit. I also could sell you a side discharge outdoor unit that's fully modulating with the inverter. They'll have the same SEER rating, but when it's running and I put my amp meter on, the inverter drive is drawing less current because the amount of time it's actually running at 100% is very, very low. So, Brett, do you feel like that answers the question?
Yeah, well, I guess it kind of brought up another question then. So just to be clear, as you're saying, SEER2 is even SEER2 didn't evolve to account for modulation and variable inverter driven systems, correct? And then in that case, would you say that those are actually performing better than they really are or worse than they really are, just in your opinion?
So, we've done, I've been involved with two projects where we were trying to get the customer a rebate through their utility company. And these
Hmm.
were these were commercial buildings. Uh, the utility company and their rebate program has turnkey rebates based on your SEER ratings. We challenge them to say, let's actually look at a year of performance.
Yeah.
And after a year of performance, both projects significantly outperformed the anticipated energy savings based on the rating on them.
Okay. So
So
the savings
I
are
can't tell you exactly how much each system is going to be, but
right.
I can tell you the two that we looked at where we monitored it,
Yeah.
it was a significantly because they said, well, if you're going from this SEER rating to this SEER rating, here's
Yeah.
what you should say ballpark.
Right.
We dramatically outperformed that going to an
Okay.
inverter system.
So these ratings are probably much more conservative when they're getting plugged into the models on what you think they're going to save, and they could actually probably be better. Is that maybe
Especially with, yes, with an inverter drive system,
right?
absolutely.
Right. Yeah, with an inverter driven system. And then I guess the next question, and let me know if you're going to cover it, but um, typically there's been thought that higher SEER equal less dehumidification. Does that play out in SEER2? Has that been fixed? Do you agree with that? Are you aware of that?
Usually when I see an issue with dehumidification, it is based upon improper sizing for the
Sure.
latent load.
Yep.
So we oversize for sensible load and we drop the temperature of the air faster than um, we get the latent heat out of the air. So the humidity is left lingering. Um, there are, with some of the inverter technology, it can it can run a warmer evaporator, which means it is less likely to remove latent heat because we're not getting below the dew point of the air. But I also feel that at least the ones that I've worked with in the last couple of years, um, I know the brand we sell, we can set up our fan operation to account for evaporator temperature. So we actually slow the fan down, which falsely um,
Hmm.
underloads the evaporator, causing it to run colder than it would need to run. But
Hmm.
that does get us more dehumidification out of it.
Hmm. Okay. Um, and then the last one that you know with the static pressure, the question I think was just here differentiating the testing protocols if you're testing a furnace only versus a total static pressure of a furnace and AC is. So is there different protocols to doing that kind of testing? Um, you know, whether it's, there's an attached heat pump or AC.
So, so if it's just a furnace, you're worried about the inlet pressure at the furnace inlet and at the
Mm,
furnace outlet. If they're You're still worried about that same measurement if you're trying to check airflow for that furnace because the furnace doesn't take into account when a furnace manufacturer provides you airflow tables, they don't provide you them with anything besides the furnace itself. Um, when you add the coil is going to increase it. And so when you design a system, you have to account for the fact that I'm going to have that coil creating additional pressure drop.
sure. Okay, thanks.
Okay. Okay, so duct design, when you're talking about SEER ratings, duct design is by far the most important thing to have on your mind. Um, a, a bad duct design, it would be like you can have the greatest furnace in the world, but if you went and bought a Cybertruck and then you threw a boat anchor out the window and drug it down the road, that Cybertruck is not going to be as efficient with the electricity it has as if it was not dragging a boat anchor. Um, the other example I use, especially if someone is in the medical industry when we're talking about terrible duct designs on their houses, is the fan is the heart of your system. It's what creates mechanical motion to move the air through. If you have a bad duct design, that's just like having cholesterol built up in your arteries and veins, and it's impeding the flow of the air. Um, and that is so crucial. Uh, Literally yesterday, I went to a guy's house who was convinced he needed more return airs in part of his house, and he had the right number of registers. We'll get into that here in just a minute, but they had six-inch runs coming off of a 1 8-inch run. And when you look at a duct design and a duct calculator, an 8-inch run can only move the equivalent of about three 6-inch runs. So that whole half of his house was getting about half of the air of what it should. And I go, well, it makes sense why it's cold over there. Um, but it took going through and explaining to him some very simple things like we have on the screen of like, this pipe is too small, stuff can't go down through it. Um, we analyze the ductwork on every HVAC system we replace because no matter how great of the equipment is, if it is poorly installed, and the biggest implication on it's poorly installed is the ductwork, it will fail prematurely. You will not get the life out of it. It will not work. So, a lot of guys will say there's some rules of thumb when it comes to duct designs. I would say point number one, there is not rules of thumb. Um, if you're operating fully based on rules of thumb, you're going to make mistakes, especially when we get to high efficiency equipment. So the one of the key differences between a high efficiency furnace and a low efficiency furnace, or the same thing can be said for an air conditioner or heat pump, is how much air you're getting through the system. Uh, Back when we had medium efficiency furnaces, we were typically looking for, an average home with a 60 to 80,000 BTU furnace was looking for between 650 and 850 CFM. Nowadays, that same furnace, it will run with 850, but most of them, when you do the calculation, would prefer to be in that 1,000 to 1,200 CFM. So we're talking about moving a third again, the air through it. If you're having your HVAC system worked on and they're not talking about the airflow, or if you're having your system replaced and they're not talking about the ductwork and the impact that has, um, I would strongly encourage you to ask questions about that. Are you sure my ductwork's okay? And if they look at it and say, "Oh yeah, it looks great," um, ask the questions. Are you sure we have the right airflow? How do we know? Um, I do have a couple of things that I use for customers uh, to help them understand kind of what we're looking for. Um, set, in our state, we have a lot of furnaces in the basement with air conditioners or heat pumps attached to them. Most of our homes are designed for a 6-inch duct run to have 80 to 100 CFM through it. So one thing I do with customers is I say, okay, let's count how many registers you have. And if we count 6 registers and they have a 2-ton air conditioner on a 60,000 BTU furnace, 6 registers is only good for about 600 CFM. Well, a 2-ton air conditioner needs 400 CFM per ton, so it needs 800 CFM. And that 60,000 BTU furnace is going to want more than that. So, one of the things that every furnace that comes from a manufacturer comes with is a recommended temperature rise. I don't know if this is in your guys' way. Okay, so if you're seeing my screen, there's this formula over to the right-hand side. CFM, cubic feet per minute, is equal to the BTUs per hour of our equipment. So that's going to be our BTU rating, divided by 1.08, which is a constant, times by our delta T. So that's our change in temperature. Now, this only works when we're talking about, this is the sensible heat transfer formula. So we do a lot of furnaces. We airflow check with furnaces a lot, and that's our preferred method. All you have to do is put the furnace in heat mode, take the return air reading, take the supply air reading. The difference in those becomes your delta T, and your furnace will have a BTU per hour rating on it. And that's going to generate a CFM that will be in the ballpark. You can also look, every furnace has a ID tag from the manufacturer, and it will have a recommended temperature rise on it. Usually, the brand we sell, their recommended temperature rise range is 35 to 65. So I pick a number in the middle and I design for that. Um, so I take the furnace we're looking at, I run it through the equation with a recommended temperature rise, that generates a CFM. I then count the registers with a customer, and that generates a CFM. If those are the same, then we have a pretty good indicator that our furnace is going to match with our duct system. However, we still go through the duct system because we can run into things like I did yesterday, where he had 12 registers. So to me, that says 1,200 CFM. He had a furnace that wanted to move 950. So I go, we should be good. 950 is less than the 1,200 CFM we should be able to move. But he had that undersized 8-inch duct feeding half of his house. So his solution was to either put a booster fan in that 8-inch duct so that it can move closer to 500 CFM, or replace the 8-inch duct with a 12-inch duct, which would also allow it to move that. So duct design, when you're talking about SEER ratings and equipment performance, is key. Go ahead, Brett.
Well, and just does everything you're saying kind of apply to especially existing homes who want to convert to heat pump through electrification? I know that if I understand right, there are even slightly more challenges to make sure those are able to deliver enough heat, especially in improperly, sized ductwork, if you may.
Yes, absolutely. So the rule, the rule that's been used for years when it comes to air conditioners and heat pumps is 400 CFM per ton. Now,
Mhm.
in different parts of the country, you'll see that change a little bit
Right.
depending on if you have a sensible load or a latent load and what it may be. Um, so if I have a home that has a 60,000 BTU heating load, if I let me pull the calculator up on here. Can you guys see my calculator app, or do I have to
You
actually?
have to reshare it. You have to go back in the sharing. Yeah.
Yeah, okay. That's what I was thinking. Okay. All right. Can you see the calculator now?
Yep.
So if I have a 60,000 BTU furnace, and if I take that number and I divide it by the 1.08, which is my constant, and then I take that number and divide that by my delta T, which is designed, we're just going to say it's 50 degrees. That's usually right in the middle. So this furnace, if I was installing a furnace with a 60,000 BTU heating capacity, I would design my duct system for 1111 CFM. Um, I've got a duct calculator on my phone. Let me sure that would be, it's probably going to be like an 8 by, so we'll just punch in 1100.
I think everyone's question is now, how do I get a duct calculator on my phone too?
Oh,
You don't have
what
to
is the
answer
app
that. I
called?
just, yeah, that's the, I'm
It's
like,
it's free.
yeah,
And that's why I use it.
yeah.
So if I hold this up here, is that backwards to you guys?
Nope.
Okay. So 1100 CFM, we're looking at like an 8 by 28 or 16-inch round. It tells me all these different options it could be, right?
Yeah.
We're going to go with 8 by 28 and remember that just because we'll see how that changes. Now, if I take the same 60,000 BTU load and I apply a heat pump to it, I need to move 400 CFM per ton. So 400 CFM times by 60,000 BTUs, 60,000 divided by 12,000 is 5. So this is a 5-ton load. So I need to move 2,000 CFM. So I need to move almost double the CFM. And if I punch 2,000 CFM in, let's see, do I even get an 8 by option? I
Mm-hmm.
don't. 34 by 10.
Yep.
I went from a 16-inch round to a 20-inch round. So the ductwork requirements are huge compared to that. Uh, Generally, and my recommendation for our customers is if we're going down the heat pump route, unless we are have the opportunity to gut everything out of it, um, we pretty much have to um, go with like a dual fuel application. So we keep some capacity of fossil fuel heat. The other thing you could do is you could design for that, 1200 CFM, which would be 3 ton of heat pump, which that would get you 36,000 BTUs. It would get you uh, close to your total heat load, but you would need to supplement probably with electric heat. Um, and in the state of Michigan, if you're supplementing with electric heat, you're not going to realize quite the energy savings you would in
Yeah.
other
Yeah.
fuels.
Yeah. Yeah.
Excuse me, I should not say energy savings. I should say cost savings.
Cost savings. Right. Yeah.
So yes,
Yeah.
and that just boils down to cost of BTUs depending on the fuel you're getting. So
Right.
so
Yeah.
that is that's a challenge we've ran into, and that's where we've looked at like dual fuel. So we're still getting the heat pump and the electrification, but
Yeah.
we are not having to redo, $7,000 to $12,000 worth of ductwork in a house.
Yeah. Yeah.
Now, if it's a new house and you can build to it, then absolutely build to it.
Right. Right. Well, certainly there's some more questions on ducts and HVAC, but we want to make sure we get to the other part here on
Yes, yeah,
refrigerant. So
absolutely.
I'll let's get back to those ones a little bit later. So
Okay. So the other term we're hearing recently is this refrigerant change. We've got this new A2L. My question is it dangerous? I've heard stories from other people in my industry about how I had one guy say, "Well, I'm retiring because I don't want to blow up." And I'm going, "But you work on furnaces, right? Those furnaces that have natural gas or propane pumped to them, you know, that propane system that has a 500-gallon tank sitting outside with a 1-inch line coming into the house, like you'll work on that, but you're scared because this refrigerant might be flammable." There's a lot of confusion about that out there. So, first of all, refrigerants, I'm going to go through this quickly. Because but we want I wanted you to understand where we're at. So in the prior to 1992, everything we did was CFCs, chlorofluorocarbons. Uh, in the early 90s, we saw a shift. So your CFCs were R11, R12. HCFCs, we pivoted towards those. Those are hydrochlorofluorocarbons. The Montreal Protocol dictated that. R22 was the big HCFC. We phased that out in 20 early 2000s. 2010 was kind of the last date they could sell equipment with it. We shifted to HFCs. So your 134A or 410A, those were HFCs. Um, Both of those were driven based on lowering the ODP, which is the ozone depletion potential. CFCs, HCFCs both have chlorine in it. Chlorine was identified as a compound that could cause ozone depletion. HFCs have no chlorine, therefore they have no ODP value. It was identified that they still had a global warming potential, and so the American Innovation and Manufacturing Act said, let's start moving towards something with even lower global warming potentials. So now we're seeing the phase out of R134A in automotive, R and commercial industrial HVAC, and R410A, which for the last 15 years was our primary refrigerant used in residential systems. And we're moving towards HFOs and uh, HC. So HFOs are hydrofluoroolefins, and HCs are hydrocarbons. Hydrocarbons are our lowest GWP refrigerant, and we'll talk about where some confusion comes with what we're talking about. Um, so all refrigerants, and I apologize that this isn't as clear as it could be. All refrigerants are rated on this classification scale. Um, the first column is column A, and those are A refrigerants. They are lower toxicity refrigerants. And then the right-hand column is B, column B. Those are an increased toxicity. Pretty much all the refrigerants I've mentioned up to this moment in time have been classified as A1s. So 11, 12, 22, 410A, 134A, 407C, they're all A1 refrigerants. Um, we loved them. Uh, They were not toxic. They were non-flammable. You could burn them just for the record, and burning any refrigerant, especially one that has chlorine in it, has the potential to create phosgene gas, which is super dangerous to breathe in. And so we've always had procedures in place to prevent us from burning refrigerants. We just overlooked them a lot as an industry. So we've had A1s with the push onto these HFO refrigerants. We came out with these new classification refrigerants, and it wasn't necessarily an A1, but it really wasn't. It met the technical requirements of an A2. So the two refrigerants you're hearing about now a lot are going to be R32. Dakin, Amana, and Goodman have chosen to go the R32 route. And then the other refrigerant is R454B. Everybody else went to 454B. Now, just so you know, 454B, it's it's basically a 70-30 split between R32 and R1234YF. The automotive industry went R1234YF. Um, so if people say, if you're saying, I don't want to have this R32, like every piece of new refrigerant is coming with some level of R32 in it. The question is it pure R32 or is it mixed with 1234YF? Um, there are some reasons I prefer R32 that I'd be more than happy to share over the other, but I won't waste your time with that right now. Um, so because R32, let me back up. Our 410A that we've been using since 2010 exclusively was a 50-50 mix between 32 and 125. Mixing 32 50%, 50-50 with 125 made it move from an A2 classification to an A1. So the 125 was acting as a fire suppressant inside of it. Um, so if you have a 410A system out there, you also have R32 in your system. So we don't need to be scared of R32. It's been out there, it's going to be out there. It's just what we have to deal with. So let's understand what it really means. What is an A2L? An A2L is an A, non-toxic, two, flammable, but they added this L designation because it has a low burning velocity, meaning um, if it catches on fire and you remove the flame from it, it will not continue to burn on its own. Um, so are they flammable? Yes. Is it flammable like an A3? No. Um, so there are some additional considerations we need to take when talking about A2L refrigerants. Number one is we need to make sure that if we're working on these systems, we have a leak detector that's capable of detecting it. Um, so just making sure we have some compatibility with there. Uh, there is a recommendation with it that your recovery equipment, so your recovery machine, is rated for an A2L, meaning it's spark free. The other things, so nitrogen purge regulator, uh, best practice has always been to purge with nitrogen so that we keep our system as dry as possible. It's just a little bit more important now that we have these A2Ls. A2L tanks do come with a left-handed thread on them. So much like your propane grill tank comes with a left-handed thread, A2L tanks come with a left-handed thread. So you may need a tank adapter for that. And then the other thing I love about where our industry is going is the technology with refrigerant probes. So now I can put my two refrigerant probes as shown in the bottom corner here, and you can pick whatever brand you want, doesn't matter. They just had a nice picture of this field piece set. So the two probes in the middle, I screw those on, and I'm taking no refrigerant from the system or hardly any refrigerant from the system. And I connect to it via Bluetooth and I tell it what the refrigerant is, and it just communicates so I don't have to look at gauges and convert pressures to temperatures and charts. Um, to me, it makes it much more simple to service, and you can document stuff a whole lot better, which as a contractor to me is the real benefit. Now, a lot of people are saying, well, this new refrigerant is propane based. Propane is a refrigerant. It is an A3 refrigerant. So A3 refrigerants are highly flammable. We are allowed to use A3 refrigerants, specifically two listed over here on the right. R290, which is propane. It is pure propane. The stuff in your grill tank is not pure propane. So they recommend not using it. You could lose 3 to 6% capacity of the system. The other is R600A, which is isobutane. Both of these are naturally occurring hydrocarbons. We have made the decision, by we, I mean the government that is in power, the government agencies have said for technician and homeowner safety, we will not put more than 150 grams or 5.5 ounces in a circuit of a hydrocarbon refrigerant. That means they're out there. If you've bought a refrigerator or freezer within the last few years, it likely has one of these two refrigerants in it, but it's limited it to small appliances, freezers, refrigerators, dehumidifiers, and things of that nature. Now, there are some additional requirements with these, like if you think you have a leak, you should be leak checking immediately with something that's going to pick up 5 parts per million so that you don't accidentally have a little combustible flame on your hands. Um, you still need to purge with nitrogen, so having a really good nitrogen regulator. You also need to have spark-free or explosion-proof tools. So our equipment that we're using to service this needs to be rated for that. They even go as far as to say if you're working in a confined space, you may need approved ventilation, so fans and things of that nature. And then typically HC refrigerant use a much smaller hose to access it so that you have less of it available. So those are some things related specifically to the hydrocarbons. Um, in other parts of the world, they have embraced these more fully. We've limited them to small appliances. When you talk about refrigerants, we talk about getting rid of them. So if you're a homeowner here and you're going, okay, well, I've got this refrigerator, freezer, whatever it may be, and or this HVAC system that we're going to get rid of, um, even though we've went to what are natural refrigerants, there's still a requirement to dispose of that properly. So just like we couldn't cut the lines and vent it with A1 refrigerants, we still aren't doing that with A2Ls and A3s. Your technician needs to be certified. Now, this right here, this will be the first time in the last year that anybody besides me has looked at this card because it's been a year since I opened up a supply house account and had to show them. Right on that little bitty spot right there that says universal. So what's it say? Has successfully passed a universal exam on how to responsibly handle refrigerant as required. If you're going to work on basically with any of these refrigerants we listed, A1s, A2Ls, A3s, you have to have a either type 1 for small appliances, type 2 for high pressure and basically anything else, or universal, which covers type 1, type 2, and type 3. So when you're getting rid of this stuff, do your technician a favor and ask them, say, hey, where is your EPA card? Because they don't get to show it to people very often, and most of them spent like $150 to take the test to have it. So ask them and have them share it. You've got to move it in DOT approved cylinders. So we are transporting refrigerant in our vehicles. Department of Transportation approved cylinders required. Your recovery machine, I mentioned this before, needs to be rated for whatever you're removing. Um, a machine that's rated for hydrocarbons can also be used for HFCs, um, but one that's good for HFCs may not be approved for hydrocarbons. And then lastly, if you're getting rid of small appliances, the EPA does run a program called the Responsible Appliance Disposal Program, and you can sign up contractors and utilities and other groups can sign up to be partners in that. So if you're looking to get rid of stuff, and somebody shows up with a broken down truck and says, I'll get rid of it for you, likely they're not a responsible appliance disposal partner. So just keep that in the back of your mind. Look for an approved way to dispose of it. So I've got a review tab up here and then Q&A, but Brett, I'll they can read the review tab and it looked like you had a few more questions pop up, so we can jump to those.
Yeah, great. Thanks, Matt. And before we get to those questions, just a real quick reminder for everybody that yes, this session is being recorded, and you can check that recording out in the next week or so on our YouTube channel. Or you can go there right now and click subscribe, and you'll get an instant update when it is available for you. For those of you watching this in the future, but not right now on demand, make sure to take your quiz with an 80% passing rate to receive your continuing ed. And for those of you here right now, make sure to take the survey that pops up when we're done with this session, and then check your spam at certs@gutenbergcerts.com. You'll receive your continuing ed as long as you've been here for the appropriate CU hour and are logged in appropriately. And again, before we get into those questions, a huge thanks to our board of directors, our volunteers, our executive director, Jose Reyna, and all of our sponsors, especially Ream and Build Equinox, Mitsubishi, Tamarack, Panasonic, Timber HP, and Climate for supporting us and helping you achieve more sustainable building standards with your projects. So, Matt, I'm just looking at some of the refrigerant questions that came in here. And I think just to clarify, um, okay, I think someone got the answer right here. Um, well, yeah, so I think the question, there's kind of two questions here, but I'm going to kind of merge them together. I mean, the question is, you know, when do we reach the end of on the refrigerant, right? When is it that we've achieved the goal? And so then thus the other question is that CO2? Is that where we end up? Where are we headed? How long?
I mean, I was in the industry in the late 90s
Yeah.
when 410A was it. There was
Yeah.
no talk of anything happening after it.
Right.
Um, and here we are 15 years later. I do find it ironic that our phase outs have um, been very similar in length and time duration to the patents on said refrigerants and requirements. So
Hmm.
there's I don't know for sure what's happening,
Right.
but when the largest manufacturer of tools and equipment in 2010 pushes their refrigerant that requires you to buy new tools and equipment. So Honeywell owned the patent for 410A. Honeywell sold more tools and equipment for HVAC than anybody else. And ta-da,
Yeah.
that's the one we went with. It makes you go,
Yeah.
well, I don't know the answer to that, but there's enough stars wandering around that I go, my guess is it's going to change again, just like it has in the past.
Right.
Um, Ideally, there would be something that would be natural. The challenge with that being really hard to patent that and capitalize on it. Uh,
Sure.
Europe went the route of R290 for a lot of residential stuff,
Hmm.
and they seem to be happy with that. We've chosen not to. We chose to go the 410A route. Now we're choosing the 32 route, um, whether it's 454B or whatever. It's still based on 32. Um, so that's where I stop and go. I don't know. As long as there's money to be made, somebody's going to have a solution that they can make money with.
Yeah. 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 Fair enough. Um, Another question is, people who are working with HVAC, you gave some really good advice on, checking on their certifications, checking on the EPA rating, using your gut, I guess, depending on who's showing up to help you out. But I guess just to be more specific, are there any other ways you can verify that contractors are using the correct amount of refrigerant um, when they're installing these?
So I recently saw a report that said something like 80% of systems are likely not properly charged. Um, let me so I use field piece tools. My guys use field piece, the probes that I showed. And the reason we use it is they have an application that goes with it.
Hmm.
And I'm pulling it up on my phone. There's nothing live on it, but on this screen here, let's see, it's probably white, so it'll show up. So I have a screen here
Yeah.
that will tell me once I hook up my six sensors, I tell it what type of refrigerant it's dealing with. It will give me prompts for whether or not my system is performing the way it should be. And from there, um, you can be pretty close. I've actually had the opportunity to charge a system properly with it, come back a year later and examine that system, and it still was dead on the money, even though different things had changed. There's a different day, different weather, different indoor load. The app was right the day one, and it was right 365 days later. So I say, if someone's just putting a regular set of gauges on and they're saying, "Yep, looks good," I would ask questions. What's my superheat? What's my subcool? How do you know that it's properly charged? The biggest one, so Consumers Energy here in Michigan, they want you taking supply air and return air enthalpies, and they want you calculating your enthalpy per pound removed because manufacturer designed for 6.4 uh, BTUs per pound of air. And if they expect you to be within 85% of that.
Hmm. Hmm. Another very specific, detailed question is, so prior to universal refrigerant license under 40 CFR Part 82 Subpart F is no longer eligible to handle these new refrigerants. Does that ring any bells to you, that question?
It does not.
Okay.
I'm gonna have to look that up.
Yeah. Well, and we can if it's something you need to look up, we can try to
Yep,
send it
we'll
out
have to
later.
take a
So,
look at that.
yeah.
So
Um,
from my understanding was I- all of these A1, A2, A3s
yeah.
are qualified as uh high pressure refrigerants. And if you have a
Hmm.
type 2, you should be able to buy any type of high pressure refrigerant.
Okay.
If a recent regulation changed, then I've missed it since I stopped teaching the class a couple years ago.
Sure, sure, fair enough. Um, Another question that came in on the refrigerants, and I'm going to kind of answer part of it is third party commissioning of it. So I do know just we've done a session for you all to be aware of is on the ANSI 310 standard for HERS raters. They can go through and do non-invasive systems commissioning, which does include the refrigerant test. So there is training on that. But Matt, besides that, do you see anything else, or is this something that code officials are getting into under the new proposed codes?
So we last just a couple months ago, our local county had a breakfast for contractors, and they shared that when Michigan adopted the 2021 mechanical code, and it has a requirement in there for the inspector to be involved in your pressure testing for your refrigerant system
Uh,
and the evacuation of your refrigerant system. And I push as a contractor, I push back on that and say, I'm a licensed contractor. Part of that was being of good moral character, literally on the application. You have to say I'm of good moral character. So if I tell you I did something,
all right.
uh, I should my word should be good enough. However, I follow behind a lot of contractors who may or may not be licensed, and their word may or may not be good enough. So I understand um, the push for that. Um, so we're seeing some now. My local county, they have one inspector, and he basically said, we have no way that we can inspect every job that's going on.
Mm-hmm.
And so they're choosing not to enforce that right now because they do not have the manpower and staff to do that.
Yeah.
Um,
Yeah.
what'll happen in the future? I work across enough jurisdictions in my state that I found certain inspectors have certain things that they're very passionate about, and other
Yeah.
things that they don't know about.
Yeah.
Um,
Yeah.
so
The-
you got to get to know them.
Yeah. 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 Oh no, it's that sounds about right. So someone here is kind of saying, hey, I've got a drum of some refrigerant, it's communicating something different. Um, so rather than getting into the specific of that question, just to take a broader approach here, are these refrigerants on what they're labeled as to whether they're flammable or whether they're toxic or any other labels? Are these being regulated at some kind of higher level before manufacturers can send them out with the labels on them?
Should be. I noticed that question in the chat, and
Yeah,
I was a little surprised to see it labeled that way.
yeah,
Uh, my first question would be is maybe they're looking at volume.
yeah,
So the size of the container may dictate what the precautions taken with it are.
yeah.
Um, I could see that, but in general, my understanding is it could be rated as flammable, but highly flammable would be reserved for an A3 refrigerant,
Mm-hmm.
and that it would not meet the from what I've went through training wise, it would not meet the requirement for that.
Sure. So kind of switching back to SEER2 and just some of your knowledge, your general knowledge of what you have and what you have to offer and from your background and experience. Um, a question came in about duct sizing methods for really high performance homes. So like you mentioned an example of a home with the 60,000 BTU load. Like I'm like I gosh, I hope homes aren't being built like that anymore, unless they're large. But homes that are kind of getting into that passive house level where it's just so small. And so I think the question being, is that being factored in? I think the question is, yeah, just factoring in these very low load homes and their demands, and does that then allow for shrinking of the ductwork?
Absolutely. So we're building my brother-in-law is building a warehouse right now. Um, he is building it in a way that he's not approaching net zero, but his goal is to be as energy conscious as he could with his
Yeah,
12,000 square foot building. Um, when we ran an energy calculation on it, he could not believe how small the heat load was.
yeah,
So small heat load, smaller duct, and whatnot. I told him, I said, we trust the computer model. You built it, right? We put it in the way it's modeled. Uh, we we did it, and his building was perfectly comfortably warm, in this sub-zero weather we just had. So, um, definitely a new construction. It is a game changer. You will, if a contractor does not provide you with a manual J, manual S, heating, cooling,
right.
load calc, walk away because they're guessing and they're going to guess big because they don't want you to call when it is cold out and the house isn't as warm as you want. And so you're going to have oversized equipment. Oversized equipment is going to be less efficient over its lifetime than properly sized equipment.
Yeah. Yeah, and we just not the other day had a session on manual D, so very important to get that right and check that out if anyone wants to go learn more about what that is. Um, the other question that came in here was just the integration of heat recovery ventilators or energy recovery ventilators and how that might play into the impact of the SEER2 rating or just your general knowledge now. My understanding is that, especially if you can do this in a new construction, you should separate the HRV, ERV ductwork from the conditioning system ductwork if possible. But in the event that, and maybe you disagree, so go ahead and say if you do, but in the event they are combined, where does that come into play with the new SEER2 rating? Or does that change any of the approach with it?
Don't think it would change your AHRI rating numbers,
Hmm.
which are based on that. Um, I I don't see that impacting
Mhm.
that. Um, if you can keep those systems separate, I think it's also wise to keep them separate, more
Mhm.
so that if you have an ERV heat recovery tied into a normal duct system, you have no guarantee that you are distributing that ventilation air as evenly as you're supposed to.
Mhm.
If it has a totally separate duct system and layout, and you're intentionally putting that in specific locations in the home, it will get to those specific locations in the home. The biggest being, if you're ventilating out of a bathroom, you need to get the air back in the bathroom so that your
Right.
bathroom doesn't become positive or negative.
Right.
Hopefully just slightly negative for the rest of the house.
Yeah, fair enough. Um, so the other question that came in was just kind of a general, just get your general knowledge on, does it really matter if you are oversizing your system when they're modulating or variable speed as long as the low end reaches the low point? And kind of to expand on that, I like to ask this question of contractors I come across in the HVAC field is, with the weather extremes coming, we're getting hotter than we normally are. We're getting, in many cases, colder than we normally are. Do we really need systems that kind of modulate, expand, from the extreme ends, and then we just put those in, and we don't even need to worry about the calculations anymore?
See, we do a lot more service replacement than we do new construction.
Hmm.
I mean, I probably put in 10 to 1
Okay.
last year, replacements versus new construction. So when I look at a existing home, I will, I just met with a guy last week. He wants to
Mhm.
put a heat pump in, go dual fuel. We looked at his ductwork. His cooling load was basically 2 tons of cooling. He has enough ductwork to support 3 tons. And so we are going to put in a 3-ton system. It will be oversized for the cooling, but it's a modulating system. So it
Right.
can properly modulate to meet the cooling load. But it's going to be able to provide more heating, which his goal was I would like to offset as much of my heating with the heat pump as possible.
Right.
So the bigger it is, the lower we push the balance point before we have to shut that heat pump off and convert over to um, in his case, propane.
Yeah.
So I'm good with it as long as your ductwork accommodates it.
Sure. And just, like you mentioned, you're getting more into existing housing. Um, so what is your thought on getting blower door testing numbers to, ensure, I guess, more accurate predictions within the manual, Jay? Is that something you all do? Do you work with raters? Do you suggest it, or what are your thoughts there?
We we typically don't do that on our on a typical service replacement type job.
Hmm.
Um, if somebody's been in the house in any length of time, we use the old, does it feel drafty or leaky,
Sure.
and go from that. We usually use the Cool Cloud Calc app and generate a block load for a house when we're doing a replacement, which it's not as perfect as going through a full-blown manual, room by room manual J,
Right.
um, but it lets us be in the ballpark so that we know that
Hmm.
I have not ran across a house where going down a size and furnace was not easily on the table for 'em. But
Sure.
again, if you're installing a two-stage or modulating furnace, you're less concerned with it being oversized because if you can modulate down to 20% capacity, if it never gets above 80% capacity in its life, great.
Hmm.
Same thing with modulating heat pump. So we typically don't go that far in the weeds. We do it with um, is where we've been at. I do have a acquaintance that has looked at doing that and offering them blower door testing.
Hmm.
Um, and so it's something we've went down. We are seeing it happen on new construction though, for
Right.
verification.
Right. Yeah. Well, and on that note, then I wonder if those blower door tests come back different than what was anticipated. Um, are there, I know typically by that time the project is sealed up, closed, the HVAC's installed. Are they updating the calculations based on those numbers to make sure you've got the proper equipment still, or
We,
yeah, what are your thoughts on that?
I was going to say for the last new construction we wrapped up,
Yeah.
the general contractor hired extremely good subs
Hmm.
and they hit the performance we were anticipating
Right.
hitting. There
Yeah.
was a couple of things here and there that were buttoned up, but I haven't been involved with a situation where there was a discrepancy between what
Sure.
was anticipated and what we got.
Yeah.
I'm sure it happens though.
Yeah.
And you're absolutely right. What do you do when everything's sealed or, enclosed and something
Right.
like that happens?
Yeah. Um, and then what's your impression of third-party HVAC design professionals other than the HVAC sub? So, for instance, in residential design, if a homeowner does not have recommendations from the HVAC contractor, the installing contractor, um, what do you do? And in this case, they're talking specifically about like low energy homes. So
Okay, so if they working with more, do you think they're asking about working more with a design firm?
I think so. Like in the event that you get that contractor, you want to work with the installing contractor, but they haven't done a proper calculations. I think it's just, what are your thoughts on these third party HVAC calculation company, right? They're not the installer, they're just doing the sizing.
I wouldn't hire a contractor that couldn't size it
Sure.
themselves.
Yeah.
I, I guess that would be
Yeah.
that's just a red flag to me. Like
Yeah.
anybody can read an installation manual and
Right.
follow it, but the value the contractor should be bringing is they know more than just how to read the installation instructions, in my
Right.
mind. Um, the flip side of that is I've been in the industry long enough to know that there are lots of contractors out there who don't have the knowledge or capabilities of doing that.
Yeah.
And those contractors, if I was that contractor, I would be presenting that work to the customer, not having the customer go out and find somebody else to
Right.
do that. But
Yeah.
that's just me. I want my customer to see me as, their solution.
Right. Yeah. 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 That makes sense. And I think just the final question, your thought, in the industry moving forward in the new construction space, are you seeing more of an uptick in heat pumps in new construction than you've seen before? Like, what are your just anecdotal thoughts there?
We've um we've done more heat pumps. We still we still haven't gotten away from dual fuels.
Mm,
We have not done a new construction where it was nothing but or that was straight electric with heat pump, electric backup.
hmm
Um, I don't know the major reason for that outside of I think well, one drawback to that and where customers have asked this question, and yeah, I give them an honest answer. If you have a heat pump with electric heat and you lose power, what kind of generator do you need to be able to keep the house warm?
Right.
And when you start looking at some of these capacity wise, you can be looking at some pretty significant amount of backup generation needed to maintain heat in the home.
Right.
Um, and that probably is a portion of customer education. If you truly have, a well-built home and you lose power for 24 hours, you shouldn't have frozen pipes.
Right.
Your house should be able to maintain heat on its own. So that's the drawback I've seen with that. Well, but if we have a furnace, we can always run it on, a little 4,500 watt generator.
Yeah.
Um, but we saw some additional with the geothermal, like we're still seeing some of that. Um, but the challenge just being right the added install cost of the geothermal field, which those houses are, typically, straight electric, because they have that capability. But you also have to have a generator big enough to run your geothermal unit.
Right. Yeah. Yeah. That makes sense. So, all right, Matt. Well, I appreciate you sticking around here a little bit, especially after explaining you're in the emergency heat mode right now for everybody. So we'll let you get back to that. But just real quick before we wrap up, where can people go, I guess, to, reach out or learn more about
So
your organization?
DunhamService.com, Facebook, YouTube at Dunham Service. You can find us those two places as well too.
Yeah. All right, Matt. Take care. Thank you so much.
Okay. Yep. Thanks, Brett.
Yep. Bye, all. Bye.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.